So today we are going to be building a completely autonomous web browsing AI agent. Now you may have seen some really innovative technology coming out of OpenAI and companies like Manus, which allows the AI agents to control your computer. And we're actually going to be building something that allows you to do exactly the same thing locally on your machine using something called the Model Context Protocol. So let's dive in. As always, all of the code and documentation will be provided in the GitHub repository, and you can also download the blueprint directly from my Gumroad page. For this particular project, I'll be running it from the terminal. However, I'll refer back to the README file in Visual Studio Code as well, and we will also be opening up a web browser too. So the first thing, just to run through very quickly, is just to give a high-level overview of the code structure and the tech stack that we're going to be using. So if you clone or recreate this repository, you should have all of the different files that you can see in the code directory structure. The two main entry point files are the airbnb.py file and the browser.py file. These two files represent modules that will allow your AI agent to interact with MCP servers for an Airbnb service and for a web browsing service. Now there is some configuration files as well, which are stored in the config folder, one for the Airbnb MCP server and one for the browser MCP server. All the other files that you see are fairly standard, sort of like setup and hidden files that you'll see within a repository. We are going to be using the Anthropic API to be the underlying LLM for this project. So in the environment variables file, you will need to include an Anthropic API key. You can quite easily swap this out with an OpenAI API key as well, or another LLM provider too. To actually orchestrate the LLM, we'll be using LangChain. And then now we start getting into the really interesting stuff. So with AI agents, you're able to equip them with a set of tools which allows them to extend their functionality and to use external services, for example. The beauty of equipping an agent with a set of tools is that the agent dynamically decides when it should use each specific tool. You don't need to program it or hard program it to actually tell it to when to use these tools, which is the main differentiator between an AI agent and just a typical workflow. A workflow is typically very linear, whereas an AI agent dynamically decides when to use things. Now you may have heard a lot about Model Context Protocol recently, and I'm going to give a bit of an explanation around it. So when the internet first came around, there needed to be a standardized protocol upon which clients and servers were able to communicate with each other. So essentially one computer to another. And this standard protocol was the HTTP protocol. And that protocol is still used by millions of people every single day for communicating via computers and servers, or clients and servers. Then, as the internet age started to develop and we started to build more interoperable systems, sometimes there wasn't always a need for a particular client to always communicate with a particular server, but actually there were use cases for servers to talk to each other as well. And therefore a standardized protocol such as REST, and there are other protocols as well, then came around, which once again is a standardized protocol that allows servers to communicate with each other in a uniform way. And now that we're in the age of AI and AI agents, we needed a new way for AI agents to be able to communicate with services. Because up until this point, AI agents were really just expected to behave and communicate with other clients and other servers in the same way that humans or servers would. But an AI agent is a very different piece of technology to a client or a server, and therefore a new approach was needed. And this is where the Model Context Protocol comes in. It is a standardized protocol, I believe it was developed by Anthropic themselves, to provide a uniform way for AI agents to communicate with external services. If you've built AI agents before, and especially if you've used external services with those AI agents, you'll know that configuring them to call out to those external services can be a real pain. And for each AI agent, you then need to repeat that every single time. And what the Model Context Protocol allows us to do is to not have to repeat that work each time. It gives us a standardized way to communicate with external services. So rather than developing 1,000 different ways of integrating with an external third-party API for 1,000 different AI agents, you can build your 1,000 agents and just use the exact same protocol each time. I've heard it very often likened to a USB port for AI agents. It's a standardized way of plugging in external services into an AI agent. So really, MCP introduces a massive paradigm shift and a real big breakthrough, to be honest, in the AI world. Now today we're not going to be diving too much into actually building an MCP server, however I will cover this in a future video. But the focus for this video will be on how to actually integrate MCP servers with an AI agent. So the two MCP servers that we're going to be using are a web browsing MCP server. So this will use underlying technology such as Playwright and Google Chrome, and a travel service MCP server. So we're going to be using Airbnb. I'm sure you've all heard of Airbnb and Google Chrome, but Playwright essentially is an automation tool. It's typically been used for front-end development for testing websites and for automation scenarios such as web scraping. And so it provides a handy tool for us to be able to control a computer web browser. So enough chat on all that, now let's move on. So the first thing that we're going to do is we're going to set up the configuration files. So here, first of all, I'm going to copy the configuration settings for the Airbnb server. I'm going to come into the config folder and I'm going to paste this into the Airbnb MCP file. This is just a very simple JSON snippet, and it essentially provides some command line arguments to run an Airbnb MCP server locally on the machine. So very simple, and we're going to do something very similar for the web browsing Playwright MCP server. So we're going to go into the browser MCP JSON file, we're going to paste this in, and once again you can see there's some command line arguments here to start up the Playwright MCP server. Now we're going to move on to the Python modules. So the setup is actually very simple at a baseline level at least. There is a whole bunch of different configurations that you can add in here. But once again, I wanted to keep this simple for this video. Now that I've pasted the code into the Airbnb folder, let's have a look in a little bit more detail about what's going on here. So you can see from the imports that I'm importing a few different packages. I'm importing an async IO package, which will allow us to run this function in an asynchronous manner. The first thing that's happening within the main function is we're loading the environment variables. After that, we're then creating a client with the Airbnb configuration file. Now, using the MCP use Python package, it comes with some out-of-the-box AI agents and MCP clients. So for this, we're going to use just the MCP client that comes from the standard import. However, you can create your own custom MCP agents and MCP clients as well. After that, we're going to instantiate the Anthropic LLM, and we're going to create the AI agent. We'll pass some parameters in there as well, such as the LLM, the client, and the max number of steps. And then finally, as I said, this is very simple, this code. We'll try and run the query to search for some accommodations through the Airbnb MCP server. As you can see, I provided a search query here. So I want the Airbnb MCP server to find me a nice place to stay in Belfast for 2 adults for a week in August. I've added some preferences in here too as well. So I'd like a place with a balcony and somewhere with good reviews. Show me the top 3 options. And that as a baseline is it. So now I'm going to come out of here and I'm going to copy the code for the browser agent as well. And I'll paste that in here, and then let's dive into this a little bit more too. So the actual setup of the main function is very similar once again. We're loading the browser configuration file this time. We're instantiating the same chat model, the same MCP agent. The only difference really is the actual query that we're going to be running against the AI agent. So notice the query this time is no longer relevant to Airbnb, it's relevant to a Google search. And as you can see, I'm telling the AI agent to find the best restaurant in London using Google search. So what this will do, and we'll see this in action afterwards, is this will actually open up a web browser if needed, and will control the web browser and start making a search in that web browser too. Just as a human would, but essentially the AI agent is controlling it. And that's it in terms of the setup. It's really simple. You can replicate this really easily on your own machines as well. So to start off with, let's run the Airbnb agent. And as you can see, when it's complete, it prints out the results to the output. So there's quite a lot to break down here. It prints out the entire result that the AI agent came back with, but then you can see there's some intermediate steps here as well that it's come back with. It's come back with some observations. So it's told me that the Cathedral Quarter apartment is an excellent option that meets your preferences. It offers a Juliet balcony, central location, high quality furnishings, free parking space, and a perfect 5-star rating from guests. So that's, first of all, really handy. So you can see it provides some observations which are quite useful, but then it also provides a final answer as well. So underneath the final answer block, you can see it's given the Cathedral Quarter accommodation with a price, the features, even a link to the Airbnb page as well. Now, one thing I do notice here is that it actually has used the date of 2023, and I am making an assumption here that that date is based on the date of what the AI model that we're using thinks that today's date is. So you could fine-tune the LLM to have an understanding of what today's date is, but as you can see in this example, because the LLM doesn't know what today's date is, and all I said was a week in August, it's taken the date upon which the LLM thinks it is. You can see the second apartment is the Titanic Marina Review apartment, and then City Centre Getaway as well. So this is actually a really nice output, and just to reiterate, this video really is just to show you how you can integrate third-party services using MCP with an AI agent. There's obviously a whole host more configurations and improvements here that if I was to use this in a production environment, but as this is really new technology, I think this is really useful to be able to see in action. So that's great. Let's clear the screen and let's try the second AI agent. So we're going to run the browser agent. So you can see that it opens up a web browser. This is all done completely automatically by the AI agent. You can see it makes a web search. That wasn't me typing in that web search, that was the AI agent doing that itself. So it's doing this using the Playwright package. Now this is interesting. You can see that it's come back with a verification check. It thinks that I'm not a human, which in all honesty, in this case, it isn't me. I'm not doing this. That was done by the computer. That was done by the AI agent. So you can see that the AI agent's actually come back and has said that based on the snapshots that we've taken, we've gotten stuck with a Google security check page. Now this is a problem that will come around when AI agents are interacting with websites. But as the protocols get better, as the standards improve, and as websites become more interoperable with AI agents, I foresee that websites will be more accommodating towards the way that AI agents want to interact with third-party services. However, in this example, I was doing some testing before this as well, so my IP address was probably starting to get a little bit hot. But as you saw, we came across a security check page, which essentially meant that the AI agent wasn't able to carry on. However, as you can see, it's made this observation. It's identified that it actually came across this check page, and it's actually given some suggestions about how you could get around this or other ways that you could fulfill your query. In the spirit of moving forwards, we don't want to stop there. So now I'm going to come back to the browser file, and as you can see, previously we specified that we wanted Google search to make the search, but now I'm actually going to change this to specify that I want to use TripAdvisor. So by changing this to TripAdvisor from Google search, and if I run the agent again, you'll see, and once again this was sped up slightly, you'll see that it actually comes back with something, and you'll notice as well that it actually did it in headless mode. So with browser automation, you can open up an actual web browser. So Playwright can open up an actual web browser and it can essentially simulate all the clicks and all the scrolls and all the typing that a human would do. But you can also automate this process in a headless fashion, which means that a web browser isn't actually physically opened on the screen for us to see, but it does it in the background. So you can see that there's a whole bunch of different questions and thoughts that are being passed around within the AI agent here. And you can see it's making observations on the web browser. So you can see that it was able to successfully navigate to tripadvisor.com. It knows that there's usually a search bar where we can enter the information. So then what it's actually done is it's taken a snapshot of the website and it's found the search bar. Then when it's found the search bar, it's then typed restaurants in London into that search bar and it's clicked on the search button. You can see as we scroll down that it even knows that the page should now be loading with search results. So it's telling itself to wait a few seconds for the page to load completely and then take another snapshot. So you can see it then takes a waiting action and it waits for 5 seconds. And then finally, on the results page, it takes another snapshot and it's able to capture the top results as well. So then the final thought at the bottom actually tells us, based on the latest snapshot, I can see that the best restaurant in London is, in this case, the Ledbury. It's ranked number 1 on TripAdvisor. It's also given some kind of justification here as well, just to say, you know, this is based on the fact that typically the highest rated or most popular one is the first in the list. And finally, as a final answer, it kind of summarizes everything and it says, according to the search results from TripAdvisor, the best restaurant in London appears to be the Ledbury. Now, obviously, this is once again just a very simple example. In reality, in a production environment, you may not want to just rely on simply TripAdvisor. You may want to search different providers and different websites as well. But as I said, this is a really interesting example to showcase how you can integrate AI agents with MCP servers. And then also, as more and more of these MCP servers become available, how easy it is to integrate AI agents with these servers. I didn't have to do any programming here to integrate my AI agent with the API calls that were needed to be made to those different services. And in the example of the web browsing agent, I didn't have to set up anything in terms of automations, in terms of allowing the AI agent to actually open up a web browser and start performing the actions that it did. It was able to do it completely on its own. So you can start to see how this is going to open up a whole host of opportunities for AI agents and also integrating them with third-party services. So in this quick video, we have ran through how you can use the MCP use package to configure AI agents to actually communicate and make use of MCP servers locally on your very own machine. As I said before, this opens up a really interesting plethora of possibilities for AI agents. I didn't have to do any configuration, any programming, any hard coding of API calls, or any AI programming to convert an AI agent's thoughts into API calls to a third-party service, which is what would have had to have been previously done in the current way of doing things. Everything was handled by the AI agent and the MCP servers, which are already pre-packaged and ready to go. So as more MCP servers are released and become available, this is just going to enhance and expand the capabilities for AI agents. And especially the way that the technology is moving, especially with things like computer use that OpenAI have been developing, the reality of having an AI system actually completely control your computer and perform actions for you is getting closer and closer. So that's it for today. In a future video, I'll dive into how you can actually build your very own MCP servers, which can then actually communicate with the AI agent as well. But for now, let me know your thoughts in the comments, and if there's anything else that you'd like me to do, I'll see you soon.